que muchísimas gracias por esta acogida, por querer conversar con nosotros en esta jornada. Primero que nada, queremos informarle que esta actividad cuenta con traducción simultánea, para lo cual pueden seleccionar el idioma de su preferencia en el icono correspondiente, que está abajo, típicamente está abajo de su pantalla, donde hay un icono de mundo. Dicho esto, queremos darle la más cordial bienvenida al primer seminario de la serie Datos satelitales de Copernicus en Chile y América Latina, construyendo aplicaciones y redes de colaboración. Esta iniciativa es organizada gracias a una colaboración financiada por el programa Marco de Copernicus entre el Centro de Modelamiento Matemático de la Universidad de Chile en representación del Centro de Referencia Copernicus Chile y el Comité Nacional Conjunto para la Conservación JNCC de Reino Unido. Para dar inicio a este primer seminario dedicado al monitoreo del cambio climático, damos la bienvenida al señor Matt Smith, gerente de Biodiversidad, Ecosistemas y Capital Natural en JNCC, y el señor Florencio Utrera, coordinador del Centro Copernicus Relay y el Centro de Modelamiento Matemático Chile. Primeramente, Matt, por favor. No me escucha, Matt.
Good morning, good afternoon, good evening, everybody. Again, thank you very, very much for joining us. As Carmen Gloria has said, my name is Matt Smith. I am Biodiversity, Ecosystems and Natural Capital Manager at the Joint Nature Conservation Committee, JNCC in the UK. For those of you that don't know JNCC, we are a arm's length body or a non-departmental body primarily funded by the governments of the United Kingdom. We provide scientific and technical advice, impartial advice on management of natural resources and nature conservation. I'm a terrestrial ecologist and biogeographer by trade. I'm not an analyst by any sense of the imagination, and I sit very much at the science, policy, society interface within kind of the activities that I take under in my career. A really big thanks to the European Commission and to the German Space Agency, DLR, for managing the Secretariat of the Framework Partnership for Copernicus User Uptake, who have provided funding to enable this event to go forward. I would just like to say that this really is a networking event. We're not looking at this as just being a kind of a look and tell. We really see this as an opportunity to build the foundations of international cooperation within research and the application of that research. So I look forward to speaking with the rest of you later on today and some of you over the coming days for the other events. And I shall hand over to my colleague Florencio to say a few words. Many thanks.
Muchas gracias, Matt. Bueno, un gran placer el estar hoy día con todos ustedes, con este gran grupo de personas. La verdad es que no esperábamos una respuesta tan abrumadora. Ha sido genial durante estos 3 días o 4 días. En realidad tenemos inscritas alrededor de 500 personas para participar. De manera que esperamos que todo esto genere una gran cantidad de colaboración. Como decía Carmen Gloria, pertenezco al Centro de Modelamiento Matemático, donde coordino junto con el profesor Jaime Ortega el Centro de Referencia de Copernicus para Chile, y también lo que es el repositorio de datos de Copernicus para Chile. Es un placer, ha sido realmente muy grato trabajar con JNCC, con Matt Smith y con Phil en particular, con los cuales hemos trabajado a lo largo de estos meses en montar este programa y en organizar este conjunto de conferencias que, como ustedes ya saben, van a ser 5 a lo largo de 8 meses. Comenzando con esta, que tiene a su vez 4 episodios, 4 sesiones que comienzan hoy día con el tema de atmósfera. Es muy grato el poder trabajar también con el grupo de Copernicus, con el apoyo del programa de adopción de uso de Copernicus y el patrocinio de Copernicus y de la cooperación y de la Agencia Alemana del Espacio, DLR. Así que bienvenidos a todos, aprovechemos al máximo. Es una sesión que esperamos tenga una parte muy tradicional que nos va a explicar también Carmen Gloria Lavé, y una parte más revolucionaria, llamémoslo así, de formación de red a través de una plataforma. Lo que antes hacíamos en torno a un cafecito o en una sala, lo vamos a hacer en torno a una mesa virtual de trabajo. Así que bienvenidos, muchas gracias por participar y comencemos.
Gracias, muchas gracias, Matt y Florencio. Ahora dejo con ustedes a Matt Smith, quien presidirá esta sesión. Matt.
Thank you very, very much, Florencio and Carmen Gloria. So yeah, without any further ado, let us jump into the session. So the first 40 minutes of the program will be dedicated to presentations from Dr. Mark Parrington and Dr. Samuel Armand. The idea is that Mark and Samuel will speak for 30 minutes, so there will then be a 10-minute opportunity for questions and answers. So just a brief introduction. Mark Parrington is a senior scientist at the Copernicus Atmosphere and Monitoring Service, CAMS. He works in the development section at the European Centre for Medium Range Weather Forecasting, and he works on specifically wildfire emissions and emissions from anthropogenic and natural sources, and looking on the influences on global atmospheric composition. And Sam is a sectoral information systems officer, also working at the ECMWF. They are the entity. They are the entity that's implementing the Copernicus Climate Change Services (C3S) on behalf of the European Commission. So, in his role of sectoral information officer, Sam manages a diverse set of contracts which aim to showcase how the Copernicus Climate Change Services data stores and associated infrastructure can be used to deliver user-driven climate information for specific sectors. So I'm going to hand over to Mark first, then I believe Mark's going to hand over to Samuel. So Mark, it's our pleasure to welcome you. The floor is yours.
Okay, thanks, Matt, and thanks to the organisers for this opportunity to talk about the work we do in CAMS and to show you some of our data and with some examples. Could somebody just confirm quickly that you can see my presentation in full screen? Thanks, Matt.
We can see it fine, thank you.
Okay, great. Okay, thanks, Matt. Yeah, so as Matt described, I work in the Copernicus Atmosphere Monitoring Service, which is implemented by ECMWF. And so I'm just going to start with a very, very quick overview of who we are, so in case people aren't aware. So the European Centre for Medium Range Weather Forecast is a numerical weather prediction centre that brings together the member states from across Europe to address the challenges of research problems in the medium range numerical weather prediction. So that's weather prediction over the 5 to 10 to 15 day period. And the centre has been running for about 40 years, a little bit over 40 years, and we have 34 member and cooperating states. We're currently based in Reading in the UK, but we're also opening offices in Bologna in Italy. Our data centre is now based there, and the Copernicus services will be operating from Bonn in Germany soon. But we also have partnerships around the world, and we're using data relying on many other meteorological, space agencies and environmental agencies around the world. And more information can be found on our website. I'm expecting that most people attending know something about Copernicus, but this is just a very brief reminder of that. The Copernicus is the European Union's operational Earth observation and monitoring program. It's launching satellites called the Sentinels And data from those sentinels, along with other satellites, feed into 6 data services, which are listed on the right. So here at ECMWF, we implement the atmosphere and climate change services, and we also contribute to the emergency management service. And always worth remembering that the bottom line of Copernicus is that all the data, the services user driven, but all the data is free and open access. Okay, so I'm going to spend the next sort of 10, 12 minutes talking about the work we do in the Copernicus Atmosphere Monitoring Service. I'm going to illustrate that with a few different examples to give you a sense of how the data can be used. So this is the overview of our portfolio, if you like. All the information can be found on our website. The link is given at the top of the slide there. But basically, we have a wide-ranging portfolio which covers all aspects of atmospheric composition. That includes emissions and surface fluxes from the surface, forecasts and analysis and reanalyses of global atmospheric composition, and atmospheric chemistry and atmospheric pollution. And these can feed into things like the ozone layer, solar radiation, climate radiative forcing. There's a wide range of applications, and I'll illustrate a couple of those. And this is all built on work by a large European consortium with about 196 entities involved, and it's all developed by contract by different entities that make an operational service that we provide the data for. And so we have an information flow that looks something like this in a very simplified form. So on the left-hand side of this slide, it's showing the observations that we use. So we're using satellite observations from about 75 different instruments. That includes also weather observations from satellite, as well as all the atmospheric composition data. But we also use ground-based and in-situ measurements from regulatory and research measurement networks. And this is typically used for evaluation and validation. These observations, they feed into our main operational data assimilation and modeling system. So at ECMWF, we run the global system. We're essentially running a weather model with all the atmospheric chemistry and tendencies and source and sink terms included to provide global information with a spatial resolution of about 40 kilometers operationally. And we also provide regional air quality forecasting for the European domain with a 9-member ensemble at higher spatial resolution. And some of the data we provide feeds into various applications, policy products, user products, and applications, some of which are sampled there on the right-hand side of the slide. So these might be mobile phone apps for air quality, such as windy.com, Breezometer, Plume Lab. But also our information is used daily and routinely for air quality forecasting by Euronews in Europe and also CNN International. So before we look at the examples, I'd just like to point out why we need CAMs. As we know, we've got all these satellites providing really excellent data. Do we really need this data service as well? And so I'm just going to illustrate this with a very quick example. So this is an image showing nitrogen dioxide tropospheric columns observed by the Sentinel-5P, the troponin instrument on Sentinel-5P, and this is from October 2018, and it's showing a region over Eastern Europe. So the blue and green and red colors are showing where the nitrogen dioxide values are, and then these black areas where there's no observations available. So, excuse me, I'm not advancing that. So these observations are essential, but to directly make use of them, it can be quite limited because we have gaps in space and time, such as these dark areas on the image shown. The observed quantities may not be directly relevant to what we need as users. So for example, this is tropospheric column of nitrogen dioxide. This is an integrated amount of NO2 that from the surface to the top of the troposphere. It reflects where the main pollution sources are and the air quality aspects of NO2, but it's not a one-for-one comparison. Also, there's a lot of satellites starting to measure these things. There's a lot of satellites that have been measuring for a long time as well. These data streams can be complex and numerous. And so what we do in CAMS is we blend together information and observations from different satellites, as well as non-satellite, with our model to provide a consistent 3D space. And with this, we can then run forecasts for a few days ahead. In the global system, there's a 5-day forecast. But we also run reanalyses over past years or decades, and I'll give a brief explanation of what that means later on. Okay, so what I'm going to show the rest of the presentation are just some examples. So this is starting with an example of our latest forecast. So these are forecasts of aerosol optical depth on the right, surface PM2.5 concentration at the bottom for the 4th of October. So these are our latest forecast information available through charts on our website. And the top left is showing the latest information we've got on observed fire locations and intensity, and focusing on South America, just to give you a sense of where you stand for the audience. And as I mentioned previously, we provide 5-day forecasts of global atmospheric composition for a number of species. We're providing 2 forecasts per day at midnight and midday UTC at about 40 kilometers spatial resolution. That's for reactive gases and aerosols. We also have greenhouse gases, so carbon dioxide, methane, and they run at a higher resolution of about 9 kilometers. So we can look at some more specific examples. I'm going to start by talking about the ozone hole. September and October are the peak months for the Antarctic ozone hole, as I'm sure most people are aware. And we have a lot of information that we can provide about this. So we provide the forecast, which is the animation on the left is showing. This is a 5-day forecast going back a couple of years. I think it's either 2019 or 2020. I'm sorry, it doesn't say the year there. And then on the right-hand side, there are 2 example profiles which are showing how our forecast compared to observations launched by balloons and ozone zones in Antarctica. And I can advance my slide. And in relation to the Antarctic ozone hole, we also have information on ultraviolet radiation at the surface. And this is another example just to give you a sense of time series of the ultraviolet index observed and predicted by CAMS at Marambio on the Antarctic Peninsula. And without going into any of the details, you can sort of pick out the correlations between the total ozone column above the sites and then look at the UV index. And you can see UV index generally increases when the ozone is decreased. And this is a product that's available through our website. I mentioned earlier about reanalysis, and I just want to take a quick diversion to explain a bit more about this. So this is using a fixed version of the model combined with observations to provide a historical period going back, in this case, to 2003, of a self-consistent data set for atmospheric composition. So you may be familiar with weather reanalysis, such as ERA 5, which Sam may mention, but we also have one for a global atmospheric composition. And more information is available on the website, and there's a paper by my colleague here, Angie Innes, about the setup for this reanalysis. And I just want to show this because, still in relation to the Antarctic ozone hole, by merging the CAMS reanalysis with the ERA 5 reanalysis, it gives us this long-term 42-year data set looking at the evolution of the Antarctic ozone hole throughout the satellite period. And again, this is data that's all available through our website, through our Atmosphere data store. And we also do active monitoring of the ozone layer. We have a page on our website, which is constantly updated with the latest information on the size and the depth of the ozone hole, and the information can be found there, and the link is included at the bottom. I'm going to move on quickly because I'm conscious of the time, and I want to talk about the things maybe more close to my interest, and this is the fire emissions. So we estimate fire emissions using our global fire simulation system. Some of the details are given here. Currently, we are using just MODIS fire power observations, but this gives us a near real-time estimate of the location, intensity of different fires around the world. And from that, we can estimate emissions and look at the smoke transport and the air quality impact. And before, actually, I'll come back to this one and just move on to this. So this is some of our latest information on monitoring fires in South America. So as I'm sure everybody is aware, in September and October is when we see a lot of fires across central parts of South America, particularly in the Amazon, across Bolivia and Paraguay, northern Argentina. And this is just to encapsulate some of that information very briefly. So on the top left of this slide, there are 2 time series which are showing the daily fire intensity from our GFAS system for the legal Amazon within Brazil, and also Mato Grosso do Sul, just to give you a sense of how recent fire activity has been compared to previous years in the GFAS data set. The animation on the right is showing organic matter aerosol optical depth, which is a proxy for the smoke transport, and we can see a lot of the smoke originating from these fires in southern parts of Brazil and other parts of Central South America, and gives us a sense of where that smoke is going and how it may affect air quality. And on the bottom left is just a quick example of some evaluation of our aerosol forecasts against aeronet measurements in Brazil, and we can see the blue dots, which are the independent measurements, compare very well with the predicted aerosol optical depth from the CAMS forecast, which is shown in the red line. The green line shows the organic matter aerosol optical depth from burning vegetation. And just before I wrap up, I want to show this example of fires in Chile back in January of 2017. And this is bringing together some different information, also from Copernicus, but in terms of fire danger forecasts from the Copernicus Emergency Management Service. So this is showing that these intense fires in central Chile through late January 2017 compared very well with what had been predicted in terms of fire danger for the region over the same period of time. And there's more information is given in an ECMWF news article from spring of 2017. And I might skip this and just point out, for more information on how we monitor atmospheric composition and the observations that go into it. A few years ago, we ran a MOOC, and all the information and the videos and the material from this MOOC are available via the link given here. There was about 5 weeks of information given, so there's many videos that provide a very comprehensive amount of information about the kind of work that we do and the kind of information that we use and also provide. And just to finish up, just want to put this slide here just to show that full access to our user support is available. We have resources for accessing and downloading the data through the climate data store, the atmosphere data store, and also other catalogs. And we have social media channels and other information available through the links given there. And with that, I think I should probably finish and hand over to Sam.
That was great. Thank you very, very much. I think, Sam, are you ready? You lined up? Wonderful.
I hope so. just see where we are with this. Brilliant. I hope you can see my screen.
We certainly can.
Brilliant. Okay, well, that's the first hurdle, which is often the most difficult. So I'm following on nicely from Mark. So Mark's really well introduced, really well introduction to the CAMS service that ECMWF implement. But I'm going to talk about the climate change service. So this is effectively known as C3S, so Copernicus Climate Change Service. And basically what we're trying to do is be more than just a portal for climate information. We're trying to ensure that any user who's using our service can get access to trusted climate information, but also we try to circumvent the need to real process and manipulate lots of information and then having to download it. We realize that climate information is what you need. You don't necessarily need loads and loads of data. So we're trying to introduce this framework, this infrastructure that allows people to actually cherry pick the information they need so it can actually support their applications, support their policy decision-making and adaptation strategies. And over the weekend, C3S has passed a very important milestone. We've now got 100,000 registered users, which is quite incredible for a service that's 5 years old, just less than 5 years old, but been operational for 2 years. And of these, 654 users actually come from Chile. So we've got a little bit of information, you know, a bit more of an outreach opportunity here to actually increase our products in Chile. So the climate data store is actually at the heart of C3S. And this is where you go, you can look at any sort of climate information you so wish. So if you're, for example, looking at the water sector, you could actually go into the CDS, you can type in water, you can look at various different products from climate projections, climate impact indices, reanalysis, regardless. And I will actually, sorry, there's someone unmuted. I don't know if it's possible to mute your microphone. Got a bit of feedback. But anyway, this is the climate data store, and this is the central part of the C3S offering. But what is in the climate data store? Well, as Mark mentioned, we have reanalysis, and reanalysis is really our workhorse for climate monitoring, but we also contain lots of satellite data. And going further back in time, we've got actually data rescue. So this could be something from like records written down in ship logs, for example, or old weather balloons that are being painstakingly and systematically digitized and incorporated into the climate data store archive. So we can actually go back and look at how climate has been changing over the last 200, 300 years, where the records exist. But more up to date, we go into the satellite era from the 1970s up to the present. And then we start to introduce something a bit different. We start to look at model data, so your climate predictions, your climate projections. So I'm going to introduce a few of our data streams. First and foremost, I think it's quite obvious that Copernicus is a remote sensing program. The majority of the money that the European Commission spends on Copernicus actually goes to the building and the launching and the maintaining of the satellites, but also the ground system networks. So a core part of our offering is actually providing systematic observations of the climate system via essential climate variables. Now, essential climate variables are identified by GCOS, the Global Climate Observing System, as essential variables for monitoring the state of our climate. And at present, C3S gives access to 22 of these 54 variables identified by GCOS. Now, this is a starting offering. We only publish those data that are scientifically robust and mature. So a lot of these ECVs are actually in their pre-operational phase, so the algorithms are currently being tweaked, but we're actually publishing the ones that are actually mature. They've got very strong quality assurance. The retrieval algorithms have been very robustly scrutinized and documented and peer-reviewed. And all the information we have in C3S is supported by a quality assurance framework. So we provide monitoring potential on the atmospheric physics, atmospheric composition, ocean variables, and the land, be it the hydrology and cryosphere, and also the biosphere. The ECVs are stable, and they provide a long-term consistent record of the climate, called the climate data record. And these are regularly updated in time, and they're accessible and traceable, as I mentioned, and available through the climate data store. One of our key offerings, as I mentioned, and as Mark alluded to, is our reanalysis product. And over the last 2 or 3 years, we've introduced a new reanalysis product. On the left, you can see Tropical Cyclone Florence from Era Interim, which is our past reanalysis. And on the right, you can see the new Era 5. And the new Era 5 product is much more, it's a higher resolution for a start, which means you can look back in time, reconstruct past weather events with much more accuracy. And here you can see the storm track has been improved. You can see the precipitation, amounts of precipitation from this storm has been much more articulately derived as a result of the improvements in our modeling and our reanalysis. And on the bottom, you can actually see the global mean temperature anomaly from Era 5, and the gradual warming of the troposphere and the cooling of the stratosphere. And we've just recently extended our back catalogue back to 1950s. So we started to now get a very good climate record and use reanalysis actually as a workhorse for global climate monitoring. As we move into the future, we provide climate predictions. ECMWF is one of the contributing member states and member organizations to our C3S multi-model seasonal forecasting product. And here we also joined by members such as DWD, which is the German weather forecasting team. And we've also got Meteo France and the UK Met Office as the UK offering. And we've recently been joined by NOAA from the United States, Canada, and also Japan, the JMA as well. We offer this multi-model product that's operationally produced and released on the 12th of every month. And here you've got the multi-model forecast, current multi-model forecast for South America, showing there's a high chance that much of South America will be warmer than the normal climatology.
Hi, right. Sam, I was just going to say, if you could just maybe just wrap it up in the next kind of three minutes or so, if possible.
yeah, okay. Okay. And we've also provided climate projections, and here we've got the CMIP global projections, but also the dynamically downscaled Euro Cordex and the Cordex models from around the globe. So these provide high resolution downscale products of the projections. Everything we produce in the climate data store actually has quality assessments, which is very good for assessing the fitness for purpose of the data. But I really want to introduce something that's quite different. So we're not only just a climate data store, we actually provide a toolbox. So it allows users to create their own applications. And here we can see how you can use the reanalysis archive and the projections to actually create your own products here. So you can start to look at the Winkler index, which is an indicator used in winemaking community to actually assess the potential of how climate change will actually impact the grapes. A lot of the information we're providing is derived products. So we're actually adding value. We're looking at new climate impact indicators. And we do this co-design process with various sectors, ranging from agriculture, energy, tourism, and try to create new products. And in this example, we're starting to look at the suitability of cod in South America. And here you can start to see how climate change is potentially impacting the suitability of commercial fishing. And I know cod is one of the important catches in South America. And here we can start to see how the thermal suitability of the oceans through modeled sea surface temperature is starting to change as we go into the future. And this may have some potential impacts looking at the viability of cod in central Chile. So here we're looking at an eco-region in southern central Chile. And we can start to see how the thermal suitability of cod is actually decreasing over time, which may mean that cod is no longer a viable commercial commodity in this region. Here I can start to present something we did for the health sector, starting to look at heat stress. We're looking at the UTCI, which is a measure of climatic suitability and thermal stress, which is taking into account humidity, temperature, wind, and radiation, which is really the benchmark for measuring human vulnerability and human susceptibility to heat stresses. And here we can start to see the most heat stressed capital cities in South America from beginning of this century to the end of the century. But what I'd like to stress is that the climate change service is actually evolving. What we're trying to do is provide more compute facilities, so it allows actually any user to create their own services without having to download the data. So in this example, we're starting to show heating and cooling degree days, which is a measure of energy use for either heating your home or cooling your home in summer. And here you can see that the heating degree days is going down, which means less heat for heating, but more energy is needed to actually cool your homes in the future. And this has all been done in the Climate Data Store toolbox. So it allows users to not download the data. You can actually do things like bias assessments, bias corrections on the fly. You can create multi-model products and actually come up with some nice applications like this for informing policy and your own developing your own applications for commercial or research purposes. So that's C3S in a nutshell. These are our Twitter handles, our Instagram handles, and things like that, should you need to find any more information. I'd just like to thank everyone for their time, and it's been a pleasure to talk to you all.
Sam, Mark, that was absolutely fantastic. Thank you very, very much on behalf of everybody for your time and your efforts for presenting this. As promised, we have a few minutes for some questions and answers before we move on to the next panel discussion. So if I can ask you to, sorry, Carmen, Gloria, how are we managing this? Can I ask you to either raise your hands or to put some your questions in the chat, please? Whilst we're waiting, I did have a quick question. You mentioned around, Sam mentioned around kind of not downloading data, but creating almost the services online. I was just wondering, is there any kind of use cases of that occurring? What does that look like in reality going forward?
Yes, so this has been one of the key pillars of the C3S offering. So we've developed something called the Sectoral Information System, which is us working with various stakeholders. We've introduced services looking at energy, agriculture, biodiversity ones we're just releasing now. And what this is really doing, this is taking the data from the climate data store. It allows the contractor to create an application which demonstrates the power of the Python scripting environment we currently operate. And there's various modules, there's various libraries in there, and Git repositories and stuff. And it allows people to make their own workflows, essentially, that actually process the data, subset the data, manipulate the data, reproject the data, and actually come out with climate information at the end. So essentially the workflow will actually read in the data rather than you having to download it, and then you can manipulate it and do the post-processing as you see fit, and then visualize the results. If you go onto our webpage, so climate.copernicus.eu, and you can search various user case studies, and then you can also go into the climate data store and actually see how these applications have been developed. All the code is open and free. So if you want to change some of the scripts, you're more than welcome to. You can copy all the workflows into your own editor, and then you can recreate the applications and manipulate them for your own uses. So everything is free and open, and that's the whole ethos behind the Copernicus offering.
That's excellent. Thank you. That is incredibly interesting. I see Luis has his hand up. Luis, if I can unmute you, the floor is yours, sir. Hello, Luis. Can you hear us?
Luis Eduardo.
Not too.
Matt,
Sí.
hay un par de preguntas en el chat.
Oh, I can't see them. They haven't come up. Can you read them?
Sí, claro, yo te la leo. Hay una pregunta de Gabriel que dice, ¿qué herramientas, estrategias, consejos para trabajar a escalas semidetalladas de manera histórica, ya no a nivel global, sino a escalas más detalladas, es posible interrelacionar escalas? ¿Alguna recomendación?
Sorry, was that aimed at, sorry, Sam, Mark, could you?
Cualquiera.
I could hear the question, Mark. Sam, could you hear the question? Would you like it to be repeated?
I only heard it in Spanish. And my Spanish is très mal, so.
Okay.
Sí, claro, con todo gusto. ¿Qué herramientas, estrategias, consejos para trabajar a escalas semidetalladas de manera histórica, ya no a nivel global, sino a escalas más detalladas, es posible internacionalizar escalas? ¿Alguna recomendación? Ah, en inglés. No,
Or is there any
no,
recommendation for
ella se le olvidó
tools
seleccionar el
for scaling
canal.
data across different timescales for this type of application?
So I assume this is related to me. So yeah, there are tools to bias correct. So for example, if you're looking at climate projections, you get, these are largely based on anomalies. So you're looking at the future. So if you create an application that looks at 2 timescales, so the past, so you're looking at reanalysis and the projections, then there often is some sort of inherited bias. So what you normally need to do is then bias correct the climate projections to ensure that the results are comparable and usable. And yes, there are some toolbox technologies, some toolbox libraries that allow you to do this. Now, as we're going into the next phase of Copernicus, so we're now in Copernicus 2, the toolbox will become much more powerful. So we're giving the toolbox additional compute facilities that will allow you to create these applications on demand. So you can actually do work on the fly to bias correct your data, to dynamic or statistically downscale it, and without the need for doing intermediate steps. So we do provide some tools to post-process the data, but these will become more and more useful as the toolbox becomes more powerful.
Thank you very much, everyone, for the questions. In the interest of time, I am going to move things on. I will remind you, after the panel, we are moving into breakout rooms where we can discuss these topics in greater detail, and we can really start to consider the types of uses or applications that you need within your own career areas or need a regional or national scale. So please do save those up and bring them to the breakout groups after the next panel session, which we're going to move into right now. I do apologize. I've seemed to have a little bit of issues with my chat updating. So I do apologize if I missed those questions. Technology let me down there. So without further ado, I am going to go into the next sessions. And first up is Professor David Large. So Professor Large is from the University of Nottingham in the United Kingdom, and he's going to be talking about carbon sinks through peatlands. David is Professor of Geosciences in the Faculty of Engineering at the University of Nottingham, and he is a member of the Geohazards and Earth Processes Research Group. David's main research expertise is in the area of peatland systems, and in particular the use of satellite measures of surface motion to quantify peat condition, peat mechanics, and quantifying the response of peat to restoration measures. So again, David, thank you very much for joining us. The floor is yours.
Pleasure. I need to be able to share my screen. You haven't enabled that.
If you click to share the screen, it should then...
It's host disabled participants screen sharing.
If our colleagues at CMM could enable David's screen sharing, that would be incredibly helpful.
Let me try now.
Hecho.
Yeah, that's good. So
fantastic. Wonderful.
Can you see that window?
We certainly can, David. Many thanks. Over to you.
I shall pop it onto display. Is that still clear?
Perfect.
Right, well, thank you very much. Thank you for inviting me to speak. So in particular, I'll be looking at the use of INSAR to monitor peatland condition, carbon accounting and hydrology, general basin hydrology, which is a slight extension beyond peat. Now, the work I'm presenting was developed between the University of Nottingham, the University of the Highlands and Islands in Scotland, and a university spin-out company, TerraMotion Limited. It's a spin-out company of Nottingham University. So, peatland, why does it matter? Well, peatland is one of our greatest carbon assets. The degradation of peatland in the UK, for example, accounts for about 4% of our total carbon emissions. And if we're going to manage that carbon asset successfully, we need to understand what condition it's in. And that matters increasingly because of the value of those carbon assets. And if you look at the potential for carbon credits in peatland and the way the peatland land value in the UK has accelerated over the past few months, you can see very strong evidence of that. In South America, you broadly speaking have two types of peatland. You've got temperate peats, and my examples will be from temperate peats in the UK, and then you've got tropical peats, and the method can also be applied to tropical peats, but I will not be discussing tropical peats today. So why do we want to measure peat condition? Well, broadly speaking, there are three reasons for doing that. We have for carbon accounting. We want to know how to account for the carbon emissions and how they may change over time within our peat. And we do that by relating the condition to the emission factors. We also want to do it for strategic management. We want to know what the baseline state is of our peat so that we can measure change relative to that baseline. And we also want to be able to quantify and judge the success of our restoration measures. So we're looking at restoration progress and the success of different restoration techniques. And then finally, we want to avoid losses, and the losses can broadly come into two categories here. We have losses due to restoration failure, but also losses due to things like bog burst, failure of the peat, structural failure of the peat, infrastructure damage to the peat, and fire, all of which we would rather avoid. So how do we approach this problem? Well, the underlying science is based on the swelling and shrinking of peat, otherwise referred to as the surface motion. And this mechanical process is intimately linked to the hydrology and the ecology, and all three are equally important to carbon storage. If a peat is nice and wet and spongy and has a dynamic surface, that will track the water table. In doing so, it will minimize oxidation, maximize carbon storage. If our peat is stiff and woody and shrubby, it can't do that. So as the water tables rise and fall, the peat will become oxidized, it will lose carbon, and ultimately will be in a poor condition. If we drain peat, we stiffen the peat structure, we collapse that peat structure, we will promote the growth of woody shrubs in the peat, and the peat will degrade. And on the right there, you've got two examples of that. At the top, you've got this is an 8-year Canadian time series measured in the field. So at the top there, you've got a nice wet dynamic peat. You can see the high amplitude seasonal oscillations up in the winter, down in the summer, tracking the changes in evapotranspiration. And in the lower example there, you've got a stiffer peat, a shrubbier peat, which has got a much more muted dynamic response to changes in water content. Now, if we were to depend on doing this through field measurements, it would be impractical. It's very, very difficult to measure this in the field. However, you can measure it using interferometric synthetic aperture radar, INSA, and that's the process that we're applying. So this is our overview of our process. We start off with our Copernicus data, which is the Sentinel-1 data. Over the UK, that's collected every 6 days. Over South America, more typically every 12 days. We then put it through a novel INSAR processing technique, which will give us virtually continuous coverage over peatland at a spatial resolution or pixel size of 20 or 90 meter pixels. And for each of those pixels, we will have a time series of surface motion. What we're interested in are the signals contained within that time series. So we take these time series per pixel, and then we apply a signal analysis to that to extract the signals corresponding to the seasonal oscillations. And if you look at the top right-hand image there, you can see two very contrasting peatland signals. The upper one shows very strong seasonality in the oscillations, and it's growing over time. The lower one, very muted seasonality in the oscillations, and it's subsiding over time. It's losing mass over time. So we process the time series and we extract a series of metrics, and these include the long-term trend, the amplitude of the seasonal oscillations, the timing. We can look at the regularity, which I won't be using today, shape, and also the underlying variance once these trends have been removed. And then we validate this in the field, and we have used over 600 sites in the flow country, which is a vast area of peatland in the north of Scotland, as our main validation area. But we have also validated more widely across other areas as well. And then that validation will lead to our application. So to give you a little more insight into that process, here we have an example in the top left there of one of our time series, and then the signals that we've extracted from it. And in particular, from this set of signals, this is a 4.5-year time series, we have extracted the amplitude and the timing of the main seasonal peak, and we've also extracted the multi-annual surface velocity. And then we plot all of these variables on the top right. So we've got a 3-dimensional plot here, which can be classified. And if you look at that plot, I hope you can see it's got 2 distinct modes. There's a bimodal distribution in there, really with respect to timing. And that's illustrated in the bottom right-hand graph. So this is a histogram of the distribution, the probability density, I guess, with respect to the timing of the peaks. And we know from that distribution that all of our drier peat, our more degraded peat, that peaks earlier in the year, it peaks in the autumn, and our wetter peat will peak in the winter time. And those are very, very strong and distinct characterizations of the peat, and they're easily classified. And then when you add into that the amplitude and the velocity, you get a much more refined classification of the peat. So a couple of examples of applications here. It's impossible to go into the fine detail of these in the time that we have, but they are good examples of doing it at a relatively large scale. So here we have 1,400 square kilometres of the far north of Scotland, the area that's referred to as the flow country. Using this classification, we can determine that this area as a whole is about 57% degraded. Most of that is eroded and drained peat. And it has a mean carbon emission using existing carbon emission values of between 6.7 and 3 tonnes of CO2 equivalent per hectare per year. And you could take a median value there if you wished. We can zoom into a smaller part of that. And within this area, it's slightly better. It's a healthier peatland. We have 46% degraded with a slightly better mean carbon emission values. So the method is very easily applied to vast areas. Our intent is to do the whole of the UK at some point and to come up with a condition map for that sort of area. If we want to look at higher resolution, this is an example of restoration progress. So this is an area that has been subject to forest to bog restoration. It was forested in peatland, and in 2015 it was restored. And what you can see here are 3 images of the evolution of this site. We have 2016-17, 2017-18, and 2018 and 19. We've classified the peat based on no progress, which is class 1, evidence of positive change or early re-wetting is another expression of that, which is class 2. Class 3 is a significant positive change or late re-wetting of the peat. And then finally, class 4 is where it develops near natural characteristics, mainly distinguished by the presence of mosses known as sphagnum mosses. And you can see that for restoration that started in 2015, we get a nice progress in that restoration trajectory because the mechanics is very sensitive to that progress. And we can see how class 1 becomes class 2 very quickly. Class 2 becomes class 3 slightly more slowly, and then eventually at an almost imperceptible pace, which is what you would expect, class 3 becomes class 4, and we gradually move towards this near natural state of the peatland. So we get a nice trajectory that is evidenced by the observations within the field. So that's peat. I thought I would throw in a South American example. It's not strictly peat, although the area is peaty. So we've also been using a similar approach to explore the hydrology of the Paramo in Colombia. And in particular, this is the Paramo Guantiva-La And what we observe here is somewhat different to what we observe in the peat over the UK. The soil is only about 10% peat, but we get two very distinctive signals within the Paramo. We have one signal which shows a strong correspondence to the wet and dry seasons. There's one main dry season in Colombia, which is the one that has been illustrated here in this particular Paramo. And then we get another one which tends to show accumulation or peaking within the main dry season. And then we can look at how these two different signals map onto the terrain. The direct response to the wet-dry seasons defines the main areas of recharge within this particular basin. And the other signal illustrates where the water is being stored. And that storage corresponds closely to the distribution of valley fill materials. So what we are seeing here is the contrast between the zones of recharge and the zones of storage, the valley fill aquifers. And we are able to use that to map their relative performance, and that includes the peat within this basin. So just to finish off then, the method works extremely well over Scotland. I expect it will work extremely well over Chile too, and Argentina and the Patagonian peatlands. It can be applied to tropical peatlands, although the signal is much noisier because they tend to be densely forested, and that requires a little bit more work. We haven't developed that as fully as we would like at this stage because our focus has been the peatlands of the UK. We have got two publications in the peatlands, which will give you a deeper understanding of what I've explained. I would point you to those publications. And then finally, if you're uncertain of that relationship between the mechanical ecology, the mechanics, the ecology, and the hydrology, we have a recent paper on that as well, which explains that relationship. And other than that, I say thank you for listening.
David, thank you very, very much. That was absolutely fascinating. And just sitting here in my mind, I can already see just a vast number of applications that such a process can really contribute to. So thank you very much for running us through that, and for the Latin American context. That was really excellent. Without further ado, I'm going to pass over to our next presenter. Can I ask everybody to just hold on to our questions for the Q&A at the end of the next two presentations. So many thanks to David. I'm now going to go over to Irina Kachan. Irina is going to talk about how she's been using the CAM service to monitor extreme climate events in Central America. Now, Irina is director for the National Center for High Technology in Costa Rica, and the center is responsible for generating knowledge and creating products and services in high technology for the promotion of high impact science and technology collaborations, promoting learning spaces, and also strengthening competitive development in the exchange of knowledge. She has extensive experience in short, medium, and long-term atmospheric forecasting, and was involved in development of the National Climate Change Strategy for Costa Rica. And her current research focuses on climate variability. So Irina, thank you so much for joining us. I can pass over to yourself. The floor is now yours.
Ok, muy buenos días. Muchísimas gracias. Y bueno, voy a compartir la pantalla. Brevemente, yo lo hago la introducción sobre qué es lo que estamos haciendo y a dónde estamos ubicados. Bueno, yo estoy trabajando en el Observatorio Climático del Centro Nacional de Alta Tecnología. Y el Centro Nacional de Tecnología pertenece al Consejo Nacional de Rectores de las Universidades Públicas de Costa Rica. Son 5 universidades públicas: Universidad Nacional, Costa Rica, Universidad Técnica, Universidad Tecnológica, UNED, y bueno, a través de este Centro Nacional de Alta Tecnología, que prácticamente impulsa mediante de alta tecnología y los espacios para vinculación de investigación, de innovación y emprendimiento en diferentes áreas, así como computación avanzada, geomática, medio ambiente, agromática, bio y nanotecnología. ¿Qué es lo que estamos haciendo? Es precisamente vinculamos las universidades, gobierno y sector agroproductivo para el desarrollo de investigación, innovación y emprendimiento. Tenemos diferentes laboratorios en SENAT: gestión ambiental, ciencia, ingeniería y materiales, biotecnología, de computación avanzada, ciencia, cultura y la sociedad. Precisamente, por falta de tiempo, voy a mencionar que gestión ambiental tenemos PRIAS, que es Sistemas de Información Geográfica y Teledetección, Observatorio Climático, a donde estamos trabajando en temas de variabilidad y cambio climático, y agromática, que trabaja con la alimentación de slow food y precisamente turismo agromático, entre otras cosas. Bueno, también quiero mencionar que es muy destacado en Centro Nacional de Alta Tecnología es la Nanotec y CENIBIOT, a donde esos dos laboratorios grandes de nano se dedica a nanoestructuras, nuevos materiales, nanobiodiversidad y así como parte de salud. También CENIBIOT trabaja en temas de salud, bioprocesos, bioprotección genómica, entre otras cosas. Y brevemente de Observatorio Climático. Observatorio Climático es un programa complementario a los servicios meteorológicos del Centro América. No está haciendo lo mismo, pero definitivamente es un programa complementario, cuya visión de Observatorio Climático es convertirse en líder y apoyo en temas de adaptación y resiliencia del sector agropecuario, principalmente ante los impactos de variabilidad y el cambio climático. Y los objetivos es principalmente promover la ciencia y tecnología, apoyar creación de capacidad, facilitar la transferencia de los conocimientos, de información, fomentar buenas prácticas agrícolas, apoyar al productor en su acción diaria y también, que lo que más importante en ese momento, brindar mayor seguridad en su producción y también, en cierta forma, impedir la migración de la población a diferentes países, así como Estados Unidos, a Costa Rica y en otros lugares. Así que esos son los objetivos principales. Para ello, nosotros desarrollamos un servicio de PIACT. ¿Qué es PIACT? PIACT es Plataforma Interactiva de Aplicación de Clima Tropical. Es una plataforma que recopila y difunde la información meteorológica, pronósticos a corto, mediano y largo plazo de múltiples centros internacionales, mundiales, de investigación. Posteriormente se hace interpretación de esta información con fin de contribuir y optimizar las actividades productivas de Centroamérica. PIACT se logra esa plataforma con fines de que cualquier persona sin tener conocimiento en meteorología o climatología, con un clic podría tener la información necesaria. Si es a corto plazo, de una semana hasta 6 meses, y así como perspectivas de El Niño, oscilación del sur. Eso precisamente la imagen que nosotros estamos haciendo de plataforma CIAC. Recopilamos la información de diferentes centros mundiales para dar la información precisa y optimizar las funciones de cualquier usuario. A través de plataforma CIAC, que se transmite la información a grupos organizados del sector agropecuario agroproductivo. No es necesariamente sector agropecuario de Costa Rica, de Centroamérica, y por medio de plataformas de redes sociales como Facebook, WhatsApp, Messenger, Telegram, YouTube, radio, televisión, brindamos conferencias, entre otras cosas. Precisamente es una información que quiero mencionar, que tenemos atención personalizada a los productores. Tenemos 28 grupos nacionales e internacionales a nivel centroamericano de WhatsApp y 13 grupos igualmente, tanto de Costa Rica como de todo Centroamérica de Telegram. Y tenemos cerca de 7,000 productores directos que atendemos el chat en forma personalizada. Como cada persona, por lo menos, reenvía la información a 5 personas más, a muy pequeño modo, grosso modo, podemos decir que el alcance es de 35,000 personas que reciben la información directa y también tiene posibilidad de hacer las preguntas. Quiero mencionar que en Centroamérica todavía hay lugares a donde hay población que no sabe leer y escribir. Es una de las herramientas que nosotros ofrecemos al público, que con su audio de voz la persona podría hacer la pregunta y nosotros, por supuesto, respondemos a la llamada, atendemos la necesidad de este productor. Hemos tenido el éxito en esta plataforma y empezamos con 15 personas. En ese momento, como menciono, tenemos más de 7,000 personas directas que reciben la información. Y precisamente, ¿qué es lo que tenemos? La información de diferentes modelos, diferentes centros, igualmente centro europeo, y nosotros tomamos información, interpretamos imagen y brindamos la información. Realmente, ¿qué es lo que necesita el usuario? Es que va a llover, no va a llover, si va a ser viento fuerte, no va a ser viento fuerte, si va a ser sequía. Y por eso es muy importante, y quiero mencionar que productos de Centro Europeo han sido excelentes, especialmente yo como que trabajo en área de los pronósticos, quiero mencionar que el pronóstico del viento en la altura 850 milibares han sido excelentes. En varios años que estoy observando y estoy usando las imágenes, me han dado un mejor resultado para Centroamérica para predicción. Es un producto excelente. Otro aspecto que quiero mencionar, que también el pronóstico del viento, de ráfagas del viento, que también nos han dado muy buenos resultados en Centroamérica. También el viento en la altura de 200 milibares, así como el viento en la altura de 10 metros. Hace poco nosotros empezamos a utilizar los productos como viento y humedad relativa en diferentes niveles de la atmósfera, y también estamos implementando este pronóstico a mediano plazo, a una semana, realmente es a corto plazo, a una semana, que realmente está observando y está dando muy buen resultado. Tanto de la temperatura como de precipitación. Y por supuesto, como estamos trabajando en la mayor goles de variabilidad climática, es muy importante tener esta información de seasonal forecast, precisamente sobre pronóstico de comportamiento de las aguas superficiales del Pacífico, pronóstico de, así como estamos observando, de las plumas de región 3.4, que ha sido también excelente. También el pronóstico seasonal forecast de tanto de temperatura como de precipitación. No he puesto la imagen de comparación, pero quiero decir que precisamente en ese momento tenemos como una formación de un sistema de baja presión al norte de Colombia, y modelos GFS americanos estaban desarrollando un ciclón tropical en semana pasada. Incluso el viernes estaba desarrollando un ciclón tropical que podría desarrollarse el día 5. El centro europeo siempre no daba esta posibilidad de formación de un ciclón tropical. Se mantenía como una baja. Y lo que estoy observando precisamente hoy, definitivamente el pronóstico europeo ha sido excelente. Entonces, esta es muy breve mi presentación con lo que estamos haciendo y cuál apoyo estamos dando al sector agropecuario en temas de variabilidad climática y el cambio climático, que ha sido un impacto muy positivo y muy apoyado por algunas empresas nacionales e internacionales, así como la Organización de Estados Americanos. Muchas gracias.
Directora Kachan, thank you so much for a very inspirational presentation. I think it was an excellent follow-on to what we saw from Mark and Sam, to really how these services can be tailored and adapted to different regions and for different uses. It really was inspirational. Thank you so much for that. I do apologize, we're running a little bit behind time, so I'm going to go directly to our next presenter, who doesn't need much of an introduction. It is our very own Professor Utreras from the Center of Mathematical Modeling of the University of Chile. As way of introduction, Florencio is considered Chile's father of the internet, as he led in 1987 the connection of Chile to BitNet, which is an academic network which was established in 1981 at the City University of New York and Yale University. He subsequently became the head of Chile's own pioneer academic network, which in 1991 became Chile's National Network for Research in Education, known as NREN. He was pivotal in establishing the Latin American and Caribbean Internet Address Registry, LACNIC, founded the Latin American Research Networks Cooperation, and was one of the creators of the Bella Project, which was a European Commission funded effort of the research and education community to own its own spectrum on a new submarine cable, which directly links Europe to South America. So I'm going to hand over now to Florencio. The floor is yours.
Muchas gracias, Matt. Bueno, vamos a hablar del tema de los gases de efecto invernadero. La CEPAL, para aquellos que no la conocen, es la Comisión Económica para América Latina. Entre sus roles está el de coordinar acciones políticas de los gobiernos en pro de la mitigación de los efectos del cambio climático. Y ellos querían tener como una herramienta un sistema que les permitiera ver mensualmente la evolución de los diferentes gases de efecto invernadero, pero con una condición, usando solamente datos satelitales. El objetivo era contrastar con lo que estaba pasando, en particular con los inventarios de gases de efecto invernadero, y sobre todo proveer información en aquellos lugares donde hay poca información, donde en general no se generan informes con cierta regularidad. De forma que el ideal era aprovechemos lo que nos pueden entregar los satélites. Eso, por supuesto, pone ciertas dificultades. No todos los sistemas satelitales contemplan la observación de gases de efecto invernadero desde hace mucho tiempo. En particular, por ejemplo, en el dióxido de carbono existen los gases, los satélites japoneses y norteamericanos que han venido más o menos desde el 2009 entregando información, o incluso un poco antes. Y el Sentinel-5P, que fue lanzado en el 2017, como ustedes saben, y que nos está entregando información desde el 2018, desde enero del 2018, sobre un conjunto de gases. Yo me voy a concentrar en el satélite 5P, y tenía una pregunta hace un rato atrás para nuestros amigos de Copernicus, y era en particular si todo el análisis de dióxido de carbono en particular iba a ser contemplado por alguno de los satélites nuevos o se iba a mantener esta alianza con NASA respecto al uso de OCO2, OCO3, etc. Pero por ahora concentrémonos en 5P, voy a ir muy rápido porque no hay mucho tiempo. Los gases objetivos están ahí desde el ozono, el dióxido nitroso, el monóxido de carbono. Esos son los gases que permite monitorear el Sentinel-5P, que tiene un instrumento muy interesante que es el TROPOMI, que es instrumento de monitoreo de la atmósfera, que tiene una resolución espacial de 7 por 7 kilómetros y que es operado por la Agencia Europea del Espacio. Bueno, esta probablemente es más para que ustedes la vean después cuando la analicen más en detalle. Ahí están las diferentes bandas que tiene el satélite. Son varias bandas espectrales que van desde el ultravioleta hasta el infrarrojo de onda corta. Ahí están las longitudes de onda para los más técnicos, ¿verdad? Pero el satélite en particular y Copernicus nos provee un conjunto de datos preprocesados. Por supuesto, lo primero que hace, que es muy importante, es que nos entrega datos de nivel 1, ¿no es cierto?, que son todas las reflectancias, todas las radianzas en todos los 21 segmentos, 21 bandas espectrales que tiene. Pero además nos entrega a nivel 2 las columnas de los totales de todos estos gases, desde el metano, el ozono, el dióxido sulfúrico, etc. La entrega geolocalizadas, y eso es muy, muy importante. Ustedes saben muy bien que si no tenemos los datos bien geolocalizados, no podemos ubicarlos sobre el planeta, no pueden estar deformes respecto a la topografía y a la órbita del satélite, etc. De manera que es súper importante que estén geolocalizados, y lo importante es que Copernicus nos entrega los datos listos para utilizar. Incluidas también, por supuesto, las imágenes de las nubes para poder utilizar y el nivel de confiabilidad de cada uno de los datos, ¿no? Los aerosoles incluidos. Yo me voy a concentrar rápidamente en mostrarles cómo se ven. Estas, por ejemplo, así se ven las órbitas del satélite 5P. Esas son las coberturas que tiene el satélite. Y lo que tengo acá es el sitio de descarga de Sentinel-5P, que es un sitio separado por ahora del repositorio central científico de Copernicus. Todavía eso no se ha integrado, supongo que se va a integrar en un periodo no muy largo, pero es abierto acceso libre y gratuito, tal como decían Mark y Sam. Bueno, cuando uno descarga los datos, este es el tipo de cosas que ve. Así, ahí tenemos una pasada en una cierta región del mundo, que es una parte de América Latina, y se hace una pasada, otra pasada, y cuando las integro y las coloco en un sistema de información geográfico, entonces eso es lo que obtengo. Entonces, como ustedes ven ahí, tenemos zonas en las cuales las nubes nos impidieron encontrar los datos, zonas con mayor densidad de puntos, zonas con menor densidad de puntos. Entonces el problema era, bueno, ¿cómo hacemos que esto tenga un mapa en el cual estén todos los puntos? Es decir, que produzcamos la interpolación en los casos necesarios, una palabra más técnica, más matemática, en todas aquellas zonas donde no hay datos. Bueno, nosotros dijimos, bueno, lo que vamos a hacer, disculpen por esto, ahora les prometo que es la única, dijimos, cuando uno hace este tipo de cosas, típicamente la mayoría de la gente usa procesos de interpolación, es decir, de encontrar los datos que están entre medio de estos puntos que no están uniformemente colocados en el plano, dicen, bueno, vamos a usar un método tradicional, como el método, por ejemplo, de pesos de distancias invertidas, que son métodos que están hechos para el plano, pero el planeta no es plano. Entonces nosotros dijimos, no, lo que vamos a hacer es hacer lo que se llama funciones cercha o funciones spline esféricas, que se usan poco, justamente porque estas ecuaciones son un poquito enredadas, ¿no? Pero no lo son tanto si uno las programa bien y las esconde al final en un código que la gente pueda utilizar. Pero fundamentalmente el mensaje acá es que cuando uno hace interpolación de datos y sobre todo a niveles de escalas regionales, no puede asumir que la superficie sobre la cual está trabajando es plana. Bueno, eso por lo menos Colón ya nos lo dijo hace mucho tiempo, de manera que tenemos que tomar en cuenta que la superficie es esférica y utilizar las herramientas adecuadas. Ese yo diría que es el mensaje central. Una vez que uno hace eso, uno se encuentra con un segundo problema, y es que son muchos datos, muchísimos. Estamos hablando de 100.000 puntos diarios, más o menos. Entonces, cuando uno quiere integrar los datos de un mes, por ejemplo, multipliquen. Son 3 millones. ¿Cómo podrían resolver un sistema de ecuaciones complejo, lleno, no estructurado, utilizando algún sistema con 3 millones de puntos? Bueno, la verdad es que no se puede. Entonces, lo que nosotros hicimos, es algo que hace mucho tiempo descubrimos, es que uno puede utilizar zonas parciales, dado que en realidad estos sistemas tienden a tener poco efecto en largas distancias, en grandes distancias. Entonces dividimos en este caso, por ejemplo, el planeta básicamente en 13 regiones traslapadas. Y entre medio uno los pega, ¿eh? Matemáticamente uno utiliza una función para pegarlos. No se preocupen del detalle de cómo los pegamos, ¿eh? Y una vez que uno hace eso, uno lo que hace es generar una malla con los puntos ahora ubicados de manera regular, latitud, longitud, perfectamente colocados en el geoide. Y en el caso particular del sistema que tenemos, lo que nos interesaba era mirar con más detalle América Latina, entonces generamos una malla más fina en América Latina que en el resto del planeta. Eso nos permite también trabajar más rápido a nivel del sistema. Bueno, cuando uno hace eso, uno se encuentra entonces con que puede desplegar, por ejemplo, aquí tiene una concentración, esta es de dióxido de nitrógeno, de abril del 2018. Les voy a tratar de mostrar el sistema si es que me alcanza el tiempo, pero básicamente lo que uno tiene es un menú en el cual tiene los gases, tiene la región que quiere observar, uno puede observar incluso un país en particular, y el mes en que quiere observarlo. Y uno le dibuja de esa manera el mapa de concentraciones, en que aquí está la escala en la cual se está trabajando. Ahora, también puede generar series de tiempo, y eso es interesante. Por ejemplo, en este caso particular, vemos que desde el año 2017 hasta, esto creo que era abril 2018, la concentración de dióxido de nitroso ha ido subiendo. Perdón, esto es de metano, en Argentina, por ejemplo. Entonces, la herramienta básicamente lo que hace es descargar sistemáticamente los datos desde Copernicus para el caso de los gases que Copernicus monitorea. También lo hacemos para dióxido de carbono, que lo monitorea en particular OCO2 o bien GOSAT2. De manera que son otros satélites. Pero para todos estos satélites que monitorea Copernicus, los descargamos directamente desde el sitio de Copernicus en forma automática, los integramos, los consolidamos utilizando estos mecanismos de interpolación y los dejamos disponibles para que la gente construya sus series de tiempo o sus mapas de concentración en cada uno de los gases. Esto fue un trabajo que hicimos con la CEPAL, en el programa Euroclima, y yo, si me alcanza, ¿todavía me alcanza un minuto, Matt?
We're already 10 minutes over, but yes, go. One more minute, Florencio.
Nada, simplemente voy a mostrarles nada más un pantallazo del sistema. Ahí está el sistema, aquí está el sistema ya en vivo y en directo, como dicen los comentaristas deportivos. Y aquí uno elige el gas, uno elige la región, en este caso voy a tomar América Latina, y le pide que construya el mapa, y el sistema le va a construir el mapa. Ahora, si uno tiene acceso al sistema de monitoreo, uno puede ir un poquito más profundamente y decir, mire, quiero mirar una serie de tiempo y voy a, por ejemplo, tomar el índice de aerosoles entre agosto y septiembre del 2000, ese es muy lejos, digamos entre enero y septiembre del 2021, y me va a construir la curva del gas. Esto lo puedo hacer desde el momento que tengo análisis. Por supuesto que los satélites de dióxido de carbono como GOSA, TUOCO, GOSA en particular viene de 2009, de manera que tienen series más largas. Estos que vienen desde enero del 2018 no son series tan largas, pero no podemos ver máxima, mínima, media, de manera que la gente puede ir sabiendo está concentrándose más este gas o está disminuyendo, etcétera, etcétera. Bueno, eso es, cualquier consulta la respondemos después. Gracias, Matt.
Well, thank you, Florencio. Again, an excellent presentation. Very, very informative. Muchas gracias. Thank you very much. Obrigado. I apologize that we are running a little bit behind schedule, but I think it's really important to open the floor at this point for any questions or comments for any of the 5 presenters that we've heard from just now. So I'm opening up the floor. If one of my colleagues can also just watch the chat, because I seem to be having issues with it refreshing quickly. I have a hand up from Luis Eduardo. Luis, if you want to unmute yourself and ask your question, or is that a legacy hand?
Okay, ¿me escuchan ahora? Can you hear me now? Bueno, excelente. En primer lugar, quiero agradecerle al profesor Florencio. Para mí es un honor tener la posibilidad de conocerlo, aunque sea en línea. Le quería consultar si este método de interpolación tipo Kriging, curvo por así decirlo, fue desarrollado en el CMM o existía de antes, y si esta curvatura está asimilada a una sección esférica o de elipsoide.
Mark.
Go, Florencio, please.
Para romper el hielo, yo tenía una pregunta para Mark y Sam. Y era básicamente si Copernicus en los próximos satélites contempla el monitoreo del dióxido de carbono.
Okay, I can answer this
Ya la
question.
contesté.
So there is a plan on the Copernicus to have a carbon dioxide monitoring service, which will be focused on anthropogenic carbon dioxide sources. So some of this will be developed under CAMS in the coming years, where we are developing an inverse modeling system where we can take observations such as those shown by Florencio to do an inversion to estimate the emissions based on the atmospheric values from the satellite observation. And there will be satellite missions dedicated to observing carbon dioxide to address this. Those satellites have not yet been built or launched, but they will be coming in the coming years.
Thank you very much for this. I'm going to pass the microphone over to Carlos Cardenas. Carlos, if you want to ask your question.
Hola, buenos días. Mi pregunta es para David Large. Específicamente, cuando analizan las turberas, quisiera saber si analizan la coherencia y la subsidencia. Si es así, ¿qué hacen con esos dos parámetros? ¿Cómo lo obtienen específicamente?
The method we use is the ISPAS method, which is published. And you would need to go and look at that method in detail, because the INSAR data is provided by the person that developed the ISPAS method, Andrew Sauter. So I am not the ISPAS expert. But that method relaxes some of the criteria used by more traditional INSAR techniques. In particular, it will get far better coverage than you will achieve with, say, using persistent scatterers. That relaxation comes at a cost. But that cost doesn't matter greatly to us, because we're interested in the signal within the data rather than the absolute values in the data themselves. So I would refer you to the papers on ISPAS, which you'll find within the publications that are at the end of my presentation. But we do check the coherence, and we relax the criteria on coherence to be able to achieve the continuous cover that's essential to get the coverage over the peak.
Thank you very much, David. Thank you very much, Carlos. I do hope that answers your question. I have a point that I would like to raise that was in the chat from David Correa, who I believe is based in Peru. And his comment is Florencio's presentation was very interesting. However, in the case of Peru, the topography is highly varied between coasts, mountains, and jungle/forest, which can hinder some of the results. In addition to the curvature of the Earth, they are considering the high, how do we consider the high variability of topography in these types of analyses?
Is that directed to...
Me imagino que para mí, ¿no es cierto?
Sorry, that was directed to Florencio. Disculpe.
Sí, lo que quería decirte es que efectivamente la escala a la cual estamos trabajando es una escala que no nos permitiría analizar tan finamente la topografía. Ahora, ciertamente los métodos se pueden adaptar, pero habría que hacer una adaptación específica para el caso del Perú o para zonas altamente variables en topografía. Eso se puede trabajar, pero claro, este es un método más bien global, por lo tanto no tiene la resolución que tú esperarías eventualmente a nivel fino para considerar cambios topográficos muy importantes.
Wonderful. Thank you very much for the questions and for the answers. Unfortunately, we're running over time, so I'm going to draw it to a close here. Now, before we take a quick break, there is, and we move into the breakout sessions, which is really the core of this networking event. As you will remember, when we asked you to register, we asked you to identify some areas of interest for yourselves. The idea was to make this as democratic as possible when discussing the areas of collective interest. Obviously, with climate and atmosphere, there could be many, many different topics. Now, having collected all of the information from the registrations, these are the 3 topics of interest that came out on top. So in the main room, which will be chaired by my colleague Lisa, will be climate mitigation adaptation through natural and engineered processes. Breakout room, that'll be in the main room, which is this area here. Room 2 is understanding extreme climatic events, and room 2 will be data services and derived products for climate and atmosphere. Now, what we're asking you to do is we're going to give you a timed response, and that is 2 to 3 minutes based upon your area of interest. Now, what we're asking you to do is select the main room, which is the only space that will have simultaneous translation. Room 1 and room 2 will be Spanish language led. Now, please pick a room based upon your area of interest. Now, what we're asking you to do is in the main chat, either in English or Spanish or in Portuguese, write down a brief overview of what you would like to discuss in those rooms based upon the development of network project ideas. So I hope that's clear. And once you've selected your room, please note down your idea after the noting which room you want to be in. So for example, if I wanted, I will be in room 1. So I would write down MR, climate mitigation to coastal inundation, for example. So I'm going to just open the floor now. We should open the chat, which I'm hoping should be happening magically behind the scenes, for everybody to write down their ideas. And please make sure you put MR, R1 and R2 in front of your ideas. And the reason being is we are then going to do a subsequent vote on the top 3 ideas that will be discussed in the breakout rooms in the subsequent session. So I do hope that's clear. Please bear with us because this is the first event that we are running and we are just testing out new ways.
Perdón, Matt.
Tim,
Matt.
Tim, go ahead.
Es MR por la sala principal, R1 por la sala de mitigación del clima y R2 por la sala de servicios de datos. Nos habían pedido que repitiéramos los temas. Los temas son sala principal, eventos climáticos extremos. Room 1, mitigación climática y adaptación. Y en la Room 2, R2, servicios de datos y productos derivados.
That's correct.
Perfecto.
Sorry, I did put it in the chat, but I realized I sent it directly only to one delegate, so apologies. It's only been 2 years of using Zoom. So yes, if people should see that, and then if people can start responding in the chat, that would be excellent. Thank you.
Perdón, creo que no se entendió. No tienen que decir a qué sala van a ir, tienen que exponer la idea que a ustedes les gustaría que se discutiera en la sala a la cual van a ir.
Correct, yes.
Sorry, Matt, can I ask you a question?
Yes, please.
I mean, would it be better to have data services and the derived products in the room with the translations for me and Sam? Just because that's the area that we can offer the most on in terms of describing and explaining what's available and what's possible.
Okay, if you could just bear with us, because I'm just waiting to see the responses from the floor as to what people want to discuss, and then I think we can think about the logistics from there, but certainly.
Okay, thanks.
Okay, so I'm not seeing a lot of, unless there's something wrong with my chat. Florencio, can you just check if there are any ideas coming through? You're on mute, Florencio, I can't hear you.
Tengo como 6 o 7 ya aquí.
Sí. Can't see anything.
Hay algo en la configuración que no quedó bien, pero bueno, será para...
Correct. The one thing I would just check for people just to make sure that they're sending their messages to everybody, not just directly to myself. If I can just So some people are saying they can't send chats to everybody. In the chat at the bottom, it should say to. If you have the individual's name, if you click on the individual, it will bring up a drop-down menu. At the top, it will say everyone in meeting.
No se preocupen, en todo caso, yo estoy recibiendo todos los mensajes, aparentemente no quedó bien configurado, pero yo los estoy recibiendo todos y los vamos a considerar. Así que no se preocupen si no lo ven todos, porque enseguida los vamos a traspasar al sistema de votación y allí los van a ver todos. Espero que no se me quede ninguno.
Okay, excellent. So shall we draw this this opening session to a close? Let's consolidate those ideas and let's reconvene in 10 minutes, yes? Okay, excellent. I'm taking silence as good. Let's we'll be back here in about 10 minutes, ladies and gentlemen. Thank you very, very much for your contributions thus far.
Sí. Ya.
Florencio, can you hear me? Florenzio, Carmen, Gloria, can you hear me? How are we getting on?
Matt, give us a couple of minutes. We are ready.
Okay, wonderful. Thank you, Jaime.
I see you.
It's very good to see we still have 105 people online. Sometimes it's when the presentation stops, the people disappear. So that's really, really positive. Thank you. Just to let you know, our colleagues at CMM are collating all of the information and they are compiling it into polls for us to be able to vote on the top ideas for discussion in the subsequent 3 breakout rooms. If it's possible, I think we should consider making a start. Are we able to make a start, CMM colleagues? Brazil to Chile, come in Chile. Sorry, everybody. If you can just bear with us one moment, I think we're just compiling the ideas.
Bueno, hemos regresado ya de la pausa. Mientras ustedes probablemente han tomado un cafecito, aquí hemos estado trabajando un poco. Y antes de pasar a la sala, donde la idea y la invitación es a interactuar, a trabajar de manera conjunta, ya sea resolviendo algunas dudas que ustedes tengan, o bien, o más bien, trabajando en algunos temas que son de interés. Entonces ahora, antes de pasar a las salas que se van a abrir automáticamente para ustedes, le vamos a pedir que por favor voten en la encuesta que le vamos a poner a continuación. Vamos a partir con la sala 1, perdón, con la sala principal MR, es decir, esta misma sala donde estamos en este minuto, y esas son las propuestas que hicieron ustedes. Entonces les pediría que votaran por una de ellas para poder organizar el trabajo en la sala. Se cierra entonces los resultados. Y ahí están, ¿no? Están ahí, ¿no? En pantalla.
Sí, ya lo voy a cerrar.
Ok, ahí tenemos ya los resultados. Y ahora vamos a la segunda.
Yeah.
Ok, ahora tenemos las propuestas que ustedes hicieron para la sala 1, R1. Entonces le pediríamos también que votaran sobre ella.
We're not seeing any questions as yet.
Listo.
Allí ya tenemos los resultados de la segunda sala, que en este caso es la sala número 1. Y aquí ya tenemos entonces la tercera y última encuesta con respecto a la sala 2. Están ahí todas las opciones, por favor, voten. Ok, y finalmente ahí entonces tenemos los resultados de la sala 2. En este momento entonces se van a abrir las salas y ustedes van a pulsar el icono donde está la sala a la cual van a asistir y allí se van a encontrar con un moderador quien va a guiar la discusión acerca de estas temáticas que ustedes han identificado como importantes. Entonces, buen trabajo y nos vamos a ver en un rato más en la sesión principal nuevamente para ver los resultados de este trabajo y las conclusiones de este primer día.
Thank you, Carmen, Gloria. Mark, Sam, can I suggest you join in room 1, and people that would like to talk about the data services element can certainly join Lisa, myself, Mark and Sam in room 1. Thank you.
Y por supuesto, están todas las salas abiertas, entonces ustedes pueden inclusive también de pronto cambiarse de sala, salir de una y entrar a otra.
And you can select your breakout rooms at the bottom of the screen.
Matt, I seem to have some odd selection here. It's like I've got administrator rights or something that I shouldn't have. I don't seem to be able to select a room.
I'm in the same position.
I can both rooms.
Yeah, I'm also unable to select the room as well.
I'll just go with the flow.
No, es que la sala principal, si ustedes van a ir a la sala principal, se quedan en esta misma sala.
Yeah.
But I couldn't
Pero,
select
por ejemplo,
anything. I could recreate open all rooms, which would suggest administrator rights.
No hay que cambiar de sala. En el caso de las personas que van a la sala principal, se quedan en este mismo lugar.
Carmen Gloria, yo tengo que ir a la sala 1, pero no puedo seleccionarla.
Sí, ¿cómo puedo seleccionarlo?
Raúl, es la sala principal. Solamente
No, la sala 1 no es la sala principal.
Rodrigo, abajo
la
de
sala
ese
principal es la sala
breakout
principal.
room.
La sala 1, la R1, tengo que ir yo. ¿So cómo voy para allá? Ok, ahora parece que me va a dejar, ¿o no?
Si tienes
Sí,
que
ahora
ir
me
con el
dejó.
cursor.
Sí, ya ahora sí ya
Ok.
me deja. Creo.
No
me deja.
¿No las deja?
No sé cómo hacerlo.
Hola, disculpa,
Dice,
la
recrear-
función de grupos aparece y desaparece. Quizás por ahí el problema. Ahora yo no veo la función de grupos.
Bueno.
Un momento, por favor.
A un número azul que aparece al lado, si acerca el cursor,
Ya están abiertas todas las salas, espero puedan entrar. Si aún no ven, las personas que todavía no han visto, en la parte superior de la pantalla van a poder ver un punto icono azul y allí pueden pulsar para entrar.
So as we're in the main room here, we can make a start in room 1.
Por supuesto que sí.
Okay. In the interest of time, I'm going to begin chairing in this room here. This is the main room, and based upon the results, so this is understanding extreme climatic events. So the 3 top results were to look at variables and methods for observing extreme climatic events, how and where EO-derived products can consider effectiveness of nature-based solutions to mitigating atmospheric climate change impacts and adaptation, and climate change mitigation strategies and successful case studies at a global scale. Now, as the nature-based solutions one was my suggestion, I'm going to start with looking at the variables and methods for observing extreme climatic events. Now, can I ask the person who posed that question to just come forward and maybe explain a little bit around what their ideas are, and then to really open up the floor to really consider what is it you would like to see, what is it you'd like to achieve, and how is it we can, as an international network, help with this? So who was it that suggested this idea? This is the first hurdle to overcome. Would anybody like to come forward? Okay. Okay, so the person who actually posed the idea is unable to frame their comment or their question. So perhaps maybe I could open the floor to the wider audience around this topic. So just as a reminder, it's understanding the variables and methods for observing extreme climatic events. Now, we've got a range of people from various different biogeographic regions. So could I ask maybe someone who is not myself to really reflect on what it is that they've taken from these sessions, and perhaps what they would like to see in respect of the use of Earth observations in observing extreme climatic events, how it can help them in their research, but also where they think it could actually further kind of adaptation, mitigation, and application of the research on the ground. So anybody, I'm opening the floor to anybody. Gabrielle Puin, please, the floor is yours, Gabrielle.
Hola, buenas tardes, Gabriel Puin, desde Colombia. Estuve siguiendo las presentaciones y dentro de esas se mencionaba algo respecto cuando me mostraban el uso de imágenes de satélite para turberas y mostraban el tema de los páramos. En Colombia pues tenemos el páramo más grande, ¿no es cierto?, del mundo, y también tenemos una serie de características biogeográficas que hacen, digamos, unas condiciones particulares para el análisis de problemáticas ambientales, climáticas. Una de esas, por ejemplo, es esa diversidad topográfica que lleva a una cantidad de pisos bioclimáticos, de zonas biogeográficas. Esa variabilidad topográfica es generalmente una de esas variables, una de esas dificultades que tenemos para hacer, digamos, para aplicar muchas veces modelos, ¿no? Digamos, la posición geográfica de Colombia como un país ecuatorial y adicionalmente esas características biogeográficas, esas características topográficas hacen, digamos, modelos realmente complejos para, digamos, poder analizar fenómenos climáticos y variables extremas. Entonces, pues la idea sobre analizar, cuando alguien propuso esta de variables, me pareció bien interesante. El tema particularmente de topografía y pues la ubicación de Colombia en, digamos, como país ecuatorial. Quisiera saber más al respecto sobre cómo trabajar estas variables topográficas, climáticas, bajo unas condiciones de un país ecuatorial. Eso es. Gracias.
Thank you, Gabriel, very much for that. If I can open the floor, I certainly can't answer that question. I have to be completely honest. So I'm looking at really Sam, Mark, and David, or indeed Florencio, or indeed even Lisa, who is one of our analysts within JNCC, to maybe just reflect on that. And perhaps, Gabriel, when you're reflecting on the answer, maybe thinking about what that would look like in the type of project that you would like to see in equatorial countries and the kind of network that might require, perhaps. So, yeah, the floor is open for any reflections on Gabriel's comment.
Yeah, I think, Gabrielle, one of the aspects you're pointing towards there is the role of the topography and buffering what is really quite a complex climatic system. So if you take the example I gave of the Paramo, part of a larger project that was NERC funded, a Newton funded project on understanding the hydrology of the Paramo. The data that we've identified really shows a very strong influence of the topography and buffering the hydrology of the Paramo basins. And that will operate on multiple scales within Colombia, both on the scales of individual upland basins, but also on the scales of what's happening in between the very large upland areas and intervening lowlands of Colombia. So I don't necessarily have a solution for that, but I do think there may well be, in terms of modelling, but I do think there may well be means of examining how extreme climatic events impact that long-term buffering by putting in place a longer-term monitoring strategy around the behaviour of the aquifers. In our case, it was valley fill aquifers, but there could be any number of aquifers, or indeed the stability of wetlands. But it's how do you account for that buffering effect? How do you account for the lag of water as it's passing through your system? Yeah, it's complex, very complex.
Thank you, David. I see another hand up, but Mark, were you looking to come in on Gabriel's point there?
Yeah, I think so. I mean, it's a very different point to what David was making, but somewhat related. I think in terms of topography for the air quality modeling, makes it very challenging, particularly in places like cities like Bogota and indeed other places across South America and other parts of the world. And I think it was a point that occurred to me in Florencio's presentation as well, where with the question about Peru and the topography, there's a challenge for the observations, but then it's really a challenge for the modeling. And this is also true for weather prediction and climate modeling, just having the sufficiently high resolution to be able to properly represent the topography and the flows and the changes in temperature and pressure that you get as a result of that. So yeah, I mean, but like David said, it's not an easy thing to address, because the scale of the modeling needed and the high performance computing needed and a very heavy. So
When you say they're very heavy, are we looking in the realms of impossibility, or is this something that if this was an equatorial need, this is something that with investment, with time, and with a bit of, not a bit of, but significant brain power would be able to start to derive these processes and resultant outputs?
It's not impossible, but there's a cost to it, isn't there? There's the monetary cost in being able to run high performance computing to be able to do the calculations in a timely manner. And from our point of view, for doing operational forecasting, if it's going to take you more than 24 hours to run a one-day forecast, then it becomes, so I guess at the moment it's still more a research question, but I think operationally we're moving towards that. And at ECMWF for the weather forecasting, it's a combination of hardware and software to try and better represent different individual processes in models where the parameterizations don't necessarily sort of fill the gaps anymore.
Correct. Thank you for that. Jesus Anaya, I do hope I've pronounced your name correctly, Jesus. You have your hand up, so please do raise your point.
Yes, Matt, thanks. It's just about fire. As far as I know, Sentinel-2 has no what's called fire channels. So I'm wondering if Copernicus has a program regarding fire, especially forecasting these strong fire seasons.
I'm looking at Sam here, because, or Mark, by all means.
I wouldn't look at Sam, I would look at Mark, because he's the fire expert. But I would say that Sentinel-2 probably wouldn't be the instrument of choice. You do have a thermal channel, but it's not particularly suited for fire. And also because it's more of a high resolution product platform, then you're not going to get this regional view. Mark, I think it'd be more of a Sentinel-3 product, wouldn't it?
Yeah, so I think for Sentinel-2 I've seen some images. So there is imagery, of course, and imagery that's related to burned area, but yeah, it's not necessarily designed for that. Where Sentinel-3, the SLSTR instrument, is providing burnt area, but also active fire observation. So fire radiative power, it has the channels for estimating that. But it depends on what you mean by fire. I mean, in terms of the actual land surface processes, then Sentinel-3 is the thing to look at. But then also with Sentinel-5P, with the other Sentinels for atmospheric composition, there will be smoke-related products as well. So I mean, they should be related, right? But there will be information then more on the smoke as well as actually the land surface side of things.
With Sentinel-2, it could be a very useful instrument for validation. So you could see if there is a burnt area. Then you can look at more high resolution impacts, which could be used for impact modeling or something like that. But as an instrument just for assessment and monitoring, I would lean to Sentinel-3.
All right, thanks.
Thank you very, very much for that. Irina, you had your hand up next. Please, please do come in.
Muchas gracias. Bueno, definitivamente no tenemos los datos como los pronósticos de fires a gran escala y microescala también, y a largo plazo, pero sin embargo, como los pronósticos o pronosticadores que sabemos que se inicia un periodo por lo menos en Centroamérica, eso podría ser muy importante, Samuel, que si tenemos el evento de El Niño, por ejemplo, que vamos a tener en 2022, ya a partir de esta época se inician grandes incendios. Se espera que vamos a tener un evento de El Niño en Centroamérica. Tenemos muchísimos incendios forestales. Por lo tanto, es posible, por ejemplo, comparar o validar ese pronóstico tomando en cuenta los datos de los incendios que hemos tenido, por ejemplo, los años de El Niño, y así podemos por lo menos proyectar para el próximo evento. En mi caso, aunque no tenemos datos, pero la práctica muestra que definitivamente cuando tenemos este evento del Niño, tenemos un incremento muy significativo en los incendios forestales. Y además, las prácticas habituales en lo que utilizan los productores en Centroamérica, limpiar sus parcelas con quemas pequeñas, haciendo quemas pequeñas con el viento o con la sequía que se presentan quemas que es muy difícil de controlar. Y ese es el problema que tenemos definitivamente. Y otra intervención que quería hacer con respecto al pronóstico en estas condiciones de microescala. En Centroamérica, sector montañoso, tenemos influencia de los océanos, altas montañas, variabilidad de microclima, hay muchísimo. Por supuesto, predecir ninguna información satelital nos podría dar este tipo de prever esos eventos extremos. Entonces, yo creo que ahí definitivamente entra con la información satelital, entra un pronosticador, un especialista en el área, a donde podría dar una mayor advertencia a la población. Por el momento, así como estamos funcionando a nivel centroamericano, hemos tenido un buen resultado. Eso es todo. Gracias.
Thank you very much, Irina, for that. I'm sensing that wildfire is a high interest topic. Mark, would you also like to reflect on that? I see your hands raised, and I do encourage. We've only got a few minutes left, so please, anyone else that has any interventions, please do come in. Mark.
Yeah, sorry, I'm losing power. But yeah, just to reply to Irina's question, which I think is very important, is the predictability of fire is very difficult. At ECMWF, we're running 10-day forecasts of fire danger and fire weather, but tying it to things like known climate indices, El Nino, and things like this, and knowing when to expect there'll be fires, then it's at least it puts some attention on those areas. But what I wanted to say was that this might be something that's good to raise with the World Meteorological Organization. So in recent years, they've been establishing sort of wildfire early warning systems for Asia, for the sort of maritime continent region of Indonesia, Malaysia, Singapore, and there, because they have exactly the same kind of issue with big El Nino years and big fires. And there's also one for North America. So there may be thinking already around having a similar census for Central America, particularly the fire seasons in Venezuela, Colombia in recent years have been very severe in the spring, and so there may be a good cause for having a similar center or some similar expertise being brought together for the Central American region.
Yep. Also, I can add that the seasonal forecast products from C3S could be of use in this area as well. We have the multi-model products that are global. So with something like El Nino, La Nina, it could be very, these teleconnection events could be, I think there's a strong signal, so they will be, manifesting themselves in the seasonal forecast. So you can use these forecasts, you can see if there's particularly a dry year than normal, and then obviously if you can integrate these into a far weather model, for example. We do something quite similar, and the climate emergency, the Copernicus emergency service is starting to look about using the Jeff far weather index model at the seasonal scale. So there is a potential to actually expand this as a global product. I think it may be published within the Copernicus Climate Change Service Toolbox. So if that's the case, then you may be able to do some calculations yourself and create your own workflow. So I don't know, it may be on the, I don't know, Mark may know a little bit more details about this than myself, but I don't know what the plan is to implement Jeff in the toolbox, but there could be the options for, using C3S data as well.
Thank you so much for that, Sam. I'm very, very conscious of time, which is running perilously short. I'm also looking to my colleague Carmen Gloria to inquire. So we're already in the main room. I'm not quite sure if people have gone into the breakout rooms. Are we expecting people to rejoin us here for a quick summary? That's what I was expecting from the program. But just whilst I just await that confirmation, was there anybody wanting to come in on any of those comments around the fire services, about the predictability of extreme weather events, or indeed understanding the various processes which are operating, which Earth observation can help us to understand in terms of understanding with drivers or mitigation, for example? Lisa, please.
Yeah, sorry, that is not directly linked to forecasting, but since there seem to be quite a lot of interest in fire mapping and Sentinel-2 has been mentioned, I believe there's a talk tomorrow in tomorrow's session as well on exactly that topic. That would be wildfire mapping with Sentinel-2 data. So that's not forecasting, but it's looking at previous burns in areas that have been burned intentionally. So in case that's of interest to people here, they might want to come to that session tomorrow as well.
Thanks so much for that, Lisa. And yeah, that's work that JNCC has been supporting Nature Scot in Scotland, looking at fires in the uplands there, in the areas that David was actually touching on as well. So we're now at time. I'm looking to Florencio and Carmen Gloria. Florencio, Carmen Gloria, can you hear me? I'm just looking to wrap things up.
Matt, Florencio told me that we have 15 minutes more to continue the discussion. If you or we'll make a break if you want.
Okay.
See.
Well, if people are okay to hang on for that additional 10 or 15 minutes, that's absolutely fine. The agenda has us finishing at 12:30 Chilean time, 4:30 UK time. So if people are unable to stay, then I understand if you need to drop out. If there are any other points to raise, please do in the chat. So Sam has said that reanalysis and soon seasonal forecast will be available through the Copernicus Climate Data Store, CDS, while the medium range real-time forecast is available through the EFFIS and the GWIS platforms, and which will give you access to timely fire danger information at the pan-European and global scales, respectively. Thank you very, very much for that. So I think
Matt, just one point. At the beginning of the session, we have several questions. Maybe we can ask to the people who make the questions if he can explain what are their ideas about that question, what point they want to clarify.
Yes, Jaime, yes, I did open the floor to people who had actually raised the questions, but I think the individual who's done that was not forthcoming, which I understand. That's fine with the language barriers. One of the other questions that was actually was from myself was around nature-based solutions, but actually climate mitigation strategies. As we've still got a number of people on the call, I'm not sure if Irina is still on the Irina Kachan. I know that you've been available, being involved in the Costa Ricans mitigation and climate adaptation strategy. I was wondering perhaps if you could give us some reflections on your work there and how Costa Rica have been using Earth observations to inform your adaptation and mitigation strategies.
Bueno, inicialmente empezamos con la Estrategia Nacional de Cambio Climático, posteriormente de adaptación. Los cambios que lo que se presentan aunados a variabilidad climática, que realmente son muy significativos en Centroamérica. Entonces, tenemos como desde año pasado a este año, muchísima lluvia. Vamos a entrar a un periodo prolongado de extrema sequía. Y aún así, en Centroamérica, voy a hablar en general de Centroamérica, y aún así, desde Guatemala hasta Nicaragua, cuando tenemos el año realmente de mucha precipitación, aún así tenemos déficit en esas regiones. Es muy preocupante que lo que vamos a tener en próximo año, 2022 y 2023. Entonces, todo lo que hay, los reglamentos, las leyes, realmente no llegan a la población. Entonces, ¿qué es lo que nosotros estamos haciendo? Dar orientación al productor diariamente. Nos hacen a través de los teléfonos, a través de los mensajes, de redes sociales, qué es cómo ellos pueden hacer, cuándo pueden sembrar, cuándo pueden cosechar, cuándo pueden aplicar sus productos. Y en eso entramos a dar los consejos, y si no sabemos, porque en mi caso yo no soy agrónomo ni yo soy meteoróloga, entonces invitamos los especialistas para que puedan responder esas preguntas, pero damos puntualmente la respuesta al productor, y así estamos guiando a los productores. Tenemos muchísimos testimonios agradeciendo por el trabajo gracias a este servicio que estamos brindando de adaptación, que pueden tener éxitos en sus cosechas. Precisamente en ese momento, ningún servicio meteorológico de Centroamérica está mencionando que vamos a entrar en 2022 evento El Niño o patrón del Niño. Y los productores, desde ese momento, necesitan tomar acciones para obtener unas semillas más resistentes para el próximo año, para cosecha del próximo año, o implementar algunas medidas de riego. Realmente, medidas de riego son muy costosas y muy poco accesibles para el productor. Por eso, estamos preveniendo que las personas no hacen sus préstamos, no venden sus ganados, que tratan de utilizar algunas cercas vivas para el ganado, por ejemplo, que tratan de sembrar menos, si en caso del arroz, que si es arroz inundado, que tengan unas parcelas muy pequeñas para que el productor no pierda sus cosechas. Y mensualmente estamos dando un webinar gratuito, Facebook Live gratuito, a todas las personas que quieren agregarse. Posteriormente hacemos el video y enviamos a todos los miembros, 7,000 personas, miembros de los chats, que es lo que tenemos. Y así tenemos un alcance muy significativo, y gracias a este trabajo realmente hormiga, los productores han minimizado sus pérdidas. Por supuesto, siempre hay, pero han minimizado sus pérdidas significativamente. En ese prácticamente también, si el productor en esos países tan pobres, especialmente Honduras, Nicaragua, si pierden sus cosechas, hay migración, en ese momento hay mucha migración, pero si pierden sus cosechas, esa migración va a ir, la población va a ir o nuevamente a los Estados Unidos, a Costa Rica. Aquí no hay otros lugares por donde ir. Entonces tratamos con esta orientación personalizada tratamos de apoyar al productor. ¿Por qué por medio teléfono? Porque, como menciono, en estos lugares, Honduras, Guatemala, El Salvador, Nicaragua, hay muchas personas que no saben leer ni escribir, pero todos tienen sus teléfonos. Entonces, por medio de teléfono, por medio de un audio, hacen sus consultas y nosotros atendemos estas consultas personalizadas, damos orientación personalizada a cada producto. En eso consiste nuestro trabajo de adaptación. Adaptación en cierta forma resiliencia, porque gracias a este trabajo, a esos productos que ustedes tienen de predicción, de seasonal forecast, podemos hacer nosotros, en mi caso, tengo 37 años, estar en Costa Rica y trabajo más de este año en tema de los pronósticos, especialmente de variabilidad climática. Tengo una experiencia vasta para conocer también microclima y comportamiento de los eventos aunados, no solamente variabilidad solamente de Lenos, sino también de Arctic Oscillation, de North-Arctic Oscillation. Así que estamos trabajando guiando a esos productores. Disculpe por extenderme tanto.
No, Irina, thank you. I think what the points you raised there really touch on a question or a point raised by Sofia Venezuela. And she says, I'm a student of the public management and political sciences in Chile, and we are trying to understand how we link these applications to policymaking. And I understand that certain countries use mitigation tools to prevent environmentally driven social disasters. Here in Chile, we had an experience of a large city being destroyed by fire. And my question is, for example, how do you use these applications to confront these types of events? And I think what Irina and others have been saying here is the Earth observations, the tools and the techniques can really help you start to build up a much richer picture and time series, both going back and predicting forward about how the landscape is behaving and interacting with different factors. And once you can start understanding this and start programming into your models, you can start to really calculate the type of risks that come from fire, from water shortages, or even from too much water flowing through the landscapes. So I think it's once you start structuring these questions and thinking about this and really thinking about the data, there is a multitude of ways in which these services, which these applications can really help you. I'm just aware, I'm really hoping to close this in the next couple of minutes, Jaime. So if we can get everybody else back into the room, and maybe Mark, just some final reflections from you there.
Yeah, just to maybe final comment. I think this is one of the motivations behind having data services rather than just providing Earth observation data, is to make this data in a more usable form, but also having it open and unrestricted, so that exactly what Irina is talking about, developing applications for better policy or better planning for agriculture and other aspects is part of the reason. I mean, some might have better thoughts on the sectoral side of things, but at least from my understanding, that the idea is to build these applications, and that's why we provide the data in the way that we do.
Yeah. Excellent. Well, I'm going to the other rooms will be closing in a couple of minutes and be coming back to the main room. Okay, excellent. Are we all back in the main room now? I do apologize. I'm a Teams user, not a Zoom user. So trying to negotiate my way around Zoom has been an interesting learning experience. So apologies for my...
Muchas gracias, Raúl. Vamos a cerrar la sala y vamos a volver ahora a la audiencia, y ahí entonces vamos a poder hacer este resumen para el total. Van a ser de vuelta automáticamente. Gloria, ¿puedes cerrar tu micrófono?
if it looks like we're...
Bueno, ya estamos de vuelta en la sala principal. Al parecer ha habido un trabajo muy fructífero y en esta sesión Matt va a dirigirla como presidente de la sala y vamos a conocer los resultados de cada uno de los grupos que han estado trabajando en estos últimos 45 minutos. Matt?
So yes, in the interest of time, I am going to summarize very, very quickly. So we discussed a lot around the fire monitoring, how this relates to understanding risks within the landscape, and what the different capabilities are between the different sentinels. We were mentioning the uses of both Sentinel-1, but also, Sentinel-2, but also Sentinel-3. It was raised very much that Sentinel-3 may be the best instrument of choice. We did note that in tomorrow's afternoon session, there is a discussion from Duncan Blake and Nature Scott looking at the use of Sentinel-2 for mapping burn events. So there's a lot of interest around this. We also mentioned around, so building on the Costa Rican cases, really understanding how we can use data to both monitor risks at the micro scale and really fundamentally understanding the spatial configurations of risks when it comes to extreme climatic events and how the Earth observation data and data services can really be brought to bear in helping us understand and mitigate these risks. And again, there was a lot of talk around the ECMWF data services, and how this can and should be applied when using Copernicus data in exploring and answering the types of questions in this area. And then we really touched upon some of the climate adaptation strategies, and really how do you take the research and the outputs and put this into products and outputs which help decision makers that are generally non-technical audiences make better decisions. And again, we were very much talking around how this is used in spatial planning, and how we can understand the future risks and risk mitigations in the various aspects of this. So that was really a summary of what we spoke about within our section, within our breakout rooms. I shall now hand over to room 1 and room 2 chairs. Thank you.
Raúl Cordero, sala 1.
Muchas gracias, Florencio. Bueno, voy a tratar de resumir rápido, como hizo Matt, lo que conversamos en la sala 1. Ahí estuvimos hablando sobre mitigación y adaptación. Así que conversamos sobre la necesidad de contar, por ejemplo, con herramientas que permitan el mapeo y seguimiento de lo que sucede con humedales, no solamente urbanos, sino también rurales. Detectar, por ejemplo, cambios abruptos en la superficie de un humedal puede permitir identificar reducciones susceptibles de sanción. Los humedales, bueno, todos sabemos la importancia que tienen, así que el monitoreo de humedales para protegerlos es una cosa que se identificó como un tema de gran importancia. También conversamos un poco sobre los peligros glaciales, cuyas siglas en inglés son GLOF, que son usualmente aquellos derivados del derretimiento glacial. Cuando un glaciar se derrite, puede formar un gran lago, y ese lago puede experimentar un vaciamiento repentino que dé lugar a un aluvión. Entonces, el monitoreo y seguimiento del crecimiento de este tipo de lagos en zonas donde existen grandes glaciales, por ejemplo, la Patagonia, chileno-argentina, es particularmente importante. Pero no solamente es importante el monitoreo y seguimiento del lago, sino que también es importante el monitoreo satelital de zonas que pueden sufrir inundación en caso de vaciamientos repentinos de estos lagos. Entonces, herramientas satelitales primero para monitorear la amenaza creciente del lago y luego herramientas que permitan determinar zonas de riesgo donde debería no permitirse asentamientos urbanos o rurales significativos. La tercera cosa que conversamos fue herramientas satelitales que permitan distinguir distintos tipos de suelos. Había particular interés por parte de algunos quienes estaban en nuestro Room 1 sobre las turberas. Entonces, una herramienta satelital que permita diferenciar distintos tipos de suelo e identificar zonas donde hay turberas, bueno, eso parece tener particular interés, al menos fue de lo que pudimos discutir. Esos son los 3 temas que conversamos: humedales, turberas y peligros glaciares. Gracias.
Rodrigo.
Hola, sí. Bueno, en la sala número 2 hablamos de servicios de datos y productos derivados. Básicamente, uno de los primeros temas que apareció era el uso de datos climáticos, tratar de bajarlo a escalas locales, más acotadas, en las zonas de estudio o de interés. Ahí aparecieron los problemas de la grilla a utilizar y la forma de poder llevar esto a escalas locales. Entonces se conversó de la necesidad de utilización de modelos, ya sean modelos físicos o estadísticos, para poder realizar esta bajada de escala, y también poder de alguna manera calibrar estos modelos. Lo que aparentemente se evidenció es que se necesita alguna especie de colaboración o poder tener algún tipo de repositorio para poder tener, a lo mejor, compartir experiencias en cuanto a este tipo de hechos, dado que la topografía y las diferentes zonas son completamente distintas. Ese fue uno de los primeros temas que tratamos. Otro de los temas que tratamos fue experiencias que se tenían con otras bases de datos, en particular, por ejemplo, en modelos hidrológicos, para poder básicamente calibrarlos y utilizar otras bases de datos, y también datos provenientes de Sentinel-1 y 2 también se mencionó, para poder de alguna manera incorporarlo en la estimación de, por ejemplo, recursos hídricos, en cuanto por ejemplo, en utilización para agricultura y cosas de ese estilo. Ahí también se mencionó dificultades que aparecían a la hora de utilizar estos modelos, y también estas bajadas de escala, que eran dificultades computacionales, ya sea de programación y también utilización de recursos de máquina computacional. Es decir, el acceso a una máquina que permita de alguna manera realizar estos cálculos con mayor eficiencia. Esos fueron los temas básicamente tratados en la sala número 2.
Thank you so much for coming back with these ideas. I think there have been very fruitful discussions. I do apologise for the overrunning of the time, but I think it was time well spent. And living in Latin America and working with Latin Americans, I'm always told to not be so regimented with my time and so on and so forth. It stifles creativity, I'm told by my Brazilian partner. I really do want to thank you all very, very much for all of these excellent ideas. I think there is a lot to build on, and I really hope that our this wider network has found it incredibly useful to hear from David, from Mark, and from Sam regarding the work that's been going on in the UK and Europe more widely. It's been excellent to see that the join-up's already happening with these data services with colleagues in Costa Rica and elsewhere, which is just wonderful. So I do want to just hand back over to my esteemed colleagues in CMM. A huge thank you on behalf of everybody on this call to everybody in CMM for working tirelessly behind the scenes to pull this together. I'm incredibly grateful. I think it's been a really, really good first day. Again, we are learning by doing on how this is going to work, and I think it's been great. So if I can just hand back to Carmen, Gloria, Florencio, Jaime, muchas gracias.
Gracias, Matt. Efectivamente, ha sido un día muy fructífero. Ciertamente al inicio de la jornada estábamos expectantes de saber qué iba a pasar, sobre todo con esta propuesta de trabajo, de poder interactuar y compartir juntos. Así que por mi parte, no me queda más que despedirme por hoy día, porque mañana nos vemos con otra sesión muy interesante sobre ecosistemas terrestres, que funcionará de la misma manera como lo hemos hecho hoy día. Así que muchísimas gracias a todos por estar acá.
Yes, and again, and a huge thanks to our speakers as well for putting your time and efforts into this. It's been excellent. We're incredibly grateful. Thank you very much, and I hope this is the beginning of a long-standing conversation and collaboration. Once we leave our Zoom call today, and I look forward to picking up with all of you later, and we'll be certainly sharing the outputs of this workshop with all of you, and they will also be on the Chilean Copernicus Relay websites. And signposted via the JNCC websites as well, and other websites, hopefully, that of our partners. So many, many thanks to you all.
Sí, me estaban pidiendo la foto de grupo. La foto de grupo. Estoy poniendo aquí la galería completa. Y vamos a capturar la pantalla de todos los que estén presentables y visibles. Muy bien. Miren el pajarito, sonríen. Hecho. Muchas gracias.
Muchas gracias ahí a todos, a usted, a todos, Florencio, y a todos los, a Matt, a Raúl, a todos los participantes. Esperemos que mañana podamos nuevamente interactuar con ustedes. Un abrazo.
See you tomorrow.
Bye-bye. See you tomorrow. Thanks to everybody.
Bye-bye.
Ya, ahí terminé de grabar.
Bueno.
Ya.
Hola, Yolanda. Chao, Yolanda. Mucho gusto de verte. Adiós.
Gracias, Cristian.
Gracias, Cristian. Gracias, Yolanda.
Gracias a todos.